This video is about fans. The Supermicro SuperServer SYS-E300-8D that's in front of you comes with two fans. Not the three that was in some marketing pictures, so I wanted to test, since I had another fan available from an E200 in another video I just produced and you may have seen. I want to try out the system and how it performs with three fans instead of two. Now I'm going to start with this fan header disconnected, but the other two connected. Alright, and the machine is unplugged. This is an NVMe drive, Samsung SM951 with Windows Server 2016 installed and Prime 95 set to automatically start. I have another video about that, how I set all that up. Here we go. Full set of DIMMs, so 128 gig of RAM. You see 12 volts of power here, and here's the regular motherboard connector you might be used to. This machine is SFP, so I'm not going to hook up that for the power draw test. Well, I might, we'll see. But really I'm focused on the fans, and I have to ship this machine out in just a few minutes actually. So I don't have a lot of time, but yeah, we should be able to get through these basic speed tests. So first step would be to get the cover in place. I'm not going to bother to screw it down. Simple enough. Okay, and I want to point out that over here, standard profile for IPMI. Now, until I plug in the machine like this with some power, okay, and then we've got the IKDM interface or management interface hooked up for Ethernet. Until I give it power and let it boot, we're not going to be able to look at IPMI settings. In other words, if I try to refresh anything over there, it's not going to show. The system needs a little time to boot, including the IPMI device itself, a little web server built into the machine. Now, another thing to point out will be, I don't think this machine has a speaker, so you're not going to hear a beep at the end of the BIOS self-test. That's okay, basically it takes about a minute. And you're also getting a look at the watt burn as we go here. Now the results of my tests on the E200 were about 2 decibels sound decrease at both idle and under max CPU load. Also the CPU fan. The fans kept the CPU quite a bit cooler. So that's really what I'm trying to test here is, does it make sense to go ahead and add another fan to your system? So that'll be done with the boot sequence very shortly here. Once it is done, you'll hear the RPMs drop quite a bit. And you'll see the watts drop a little bit, but not much. Fans don't use up a whole lot of watts. So the CPU is still in power on self-test. It's still finishing initializing, and once it's done, we should hear the fan speed diminish quite a bit. Go to sensors. I suspect that's still going to be blank. Yep. Gotta wait just a little longer for the boot process. Now this is headless. I don't have any VGA hooked up. Like I said, that's why I went with an auto start. Okay, so I'm taking notes as we go. We're at 49 decibels. We're at 38 Celsius, but we haven't done anything yet. And RPMs, 4,600 RPMs. And 4,800 on the other. So let me write down the max number, which is what I've been doing. All right, my handwriting's horrible. I'll have an article to go with this with a nice table, but got some rough notes taken there. All right. As the machine finishes Windows booting and starts Prime 95, you will quickly hear the fan start cranking up. The room is about 70 Fahrenheit. Okay, CPU temp of 52 Celsius is much more reasonable for when an OS is running. 38 was really just a cold motherboard that had done almost nothing yet. Okay, you may have detected that the RPMs just ramped up a little bit. Mildly, just from 4800 to 4900. There's another notch. So basically it's, making decisions on temperature in a gradual fashion, trying to make sure it prevents thermal throttling and keep it at reasonable sound volumes, sound levels. All right. Now it may take a little while to crank up. I'm just going to leave the video running and publish it as is, partly to show that there's no trickery here. It's just one continuous video. But also it's 4K, which is a bit painful to edit. So let's just wait until it gets to the top. Based on the E200, it only took 3 or 4 minutes to get to that peak where it no longer kept rising. Had I left it for maybe another half hour, okay, it'd rise a little bit, but the value would be pretty minimal of waiting. So you can imagine you're doing something like a video render job or keeping the system busy. It's kind of what we're simulating here, only it's even worse abuse than that. Prime 95 by default exercises memory and CPU quite heavily. You'll notice the watt burn over on the right. So we're getting a pretty good sense of where we're at with 2 fans in the system and noise levels. (59 Celsius, 5800 RPM). So it seems like this system with its 4 cores really doesn't run that hot. I have a feeling it's going to benefit less from 3 fans than the little 6-core E200 did. So we might be done here. We're seeing no more rise, not hearing any more rise. I'm just going to record those numbers. Oh, there it is, right after I said it. So 59, 6,000. And about 53. Okay, so there's our 2 fan results. Yes, this is not a graceful shutdown of Windows. Alright, so all I gotta do now is plug in that last fan header there. One, two, 3, 4, 5, 6 fan headers in this guy, right along that back edge. Okay, as we wait for power on test, I'm going to point something out here. Brackets. This is the bracket from the E200. It's got metal on both sides, for screws on both sides. The one in here has a full bracket up front and only had 2 screws diagonally. So the one inside the E300, it's a different hunk of metal. But it's the same idea and same mount points, I believe. You got the rubberized grommets for keeping it kind of hovering in there. And there's no tool, so you just stick it in. And it seems like I believe the two are interchangeable. It's just a little difference in the metal design on the two systems. So I just wanted to point that out. Alright, as we know from the last boot, in something like 20 more seconds, we're going to hear RPM settle down. Looks like I forgot to make a watts column, so I want to do that. I'll have to look at post-production of the video. Like I said, I'll make a table of my recorded values. It'll show you the results of the E300 and E200 in a probably separate post going over all this that folks might find helpful as they try to become more educated, more informed shoppers, deciding which little system they want. Now the mini tower is far quieter than all these. Okay, here we go. Alright, so we're starting at higher Celsius. And the RPM's 4,900. There's 3 fans now, but we still have the highest one at 4,900. And decibels about 50. So that's interesting right there, because the machine is a little louder with 3 fans. I don't believe that was the case with the E200. So I'll make sure you can read that screen. Let me just adjust the focus and brightness. So we're going to wait a little bit longer. 2 minutes, we might hit the top again. We'll see. Well, that's interesting. We're already at 59 Celsius. So it appears 3 fans is doing nothing as far as cooling on this system. Well, when I said nothing, that might not be entirely true until we leave it going longer, or it's still it's less compelling, I would say. We're hitting 60 Celsius. So the way IPMI is tuned, they shipped it with 2 fans, so IPMI can be reprogrammed. Maybe they decided to handle 3 fans, well, differently or not optimally here. Because here we are hitting the same RPMs. We're not getting a benefit. Alright. Maybe we didn't get a benefit there, temperatures, but let's see how we did here. We did worse, it increased. So that's not so good. So I'd say that experiment with the fans on this guy was a fail. Okay, finishing things up would be some networking. Now this machine has a lot of network interfaces, but I have a switch right nearby to plug them in. So I'm going to go ahead and plug in all the network interfaces and see what kind of watt burn we can get this system up to. So we're at 66 watts, somewhere in there. This machine has 6 1 gig interfaces and then 2 SFP modules for 10 gig. I'm going to go ahead and plug those in. Okay, went up to 67. From my other test, it seems like each uses about half a watt, somewhere between half a watt and a watt. Okay, now we hit 68. Still no big deal. Alright, SFPs. So if I go and plug those in, for one I gotta find the SFP modules. Okay, I've got one. But for another, I've got to plug in this expensive switch, which has a loud fan. So we're kind of done looking at decibels here. And now it's time to look at the impact of plugging in an SFP module. So I'm looking for a power cord here. I'll plug this thing in, and we'll give it a go. See what we got here. So we're going to hear quite a bit of noise as this thing boots up. Takes about a minute. Okay, got it arranged so you can kind of see what's going on here. And this is not about temperature anymore, it's about watts. Go ahead and plug in one of these SFP modules. It's plugged in. We get no link layer yet because the 10 gig switch is not fully booted. So I really want to know if there's a change in watts with and without that 10 gig connection up. So we gotta wait a little longer on this Netgear ProSafe XS708T or 708T to finish booting. Let's see how we did on the sensors. Still at 61 and still at 6400. Alright. Let's see if I can find the last SFP module while we wait for that thing to boot. I traveled with it to a recent demo. Okay, sound outlet, that's good. Well, let's start with the one SFP. So we are at 58 watts. Still no light on there. Alright, that means I don't have the driver installed. It's not going to give me link layer without the driver. I believe. Let's see, this is Windows Server 2016. I'm thinking about that. Yep, I did have the 10 gig driver installed for RJ45, but it must be a different driver for Windows Server 2016 when you've got the SFP module with your X552/X557 Intel 10 gig chipset. Oh, the light did just go on and it's green. So never mind, I got the driver, so that's good. And the front bezel of the server itself is showing some nice activity LEDs there. Alright. So now, where are we at? 59 watts. Let's unplug this for a second. Under a watt for each cable. These are all short cables, mind you. This is a 2-foot cable. The other Cat 6A cables you saw me using, those thin monoprice slim run cables that people seem to like when I show them off, those are only 1 foot. So yeah, admittedly this is short cable lengths. So that's it. I believe I'm done here showing off this system. I'm able to return it to Supermicro now. I have a pretty good sense of its pluses and minuses and how it does not benefit from a third fan much. In fact, it goes the opposite direction for a home lab user that would typically want less noise. And the CPU got warmer, so just kind of a fail all around. Let's see what that CPU ended up at the end. 61. Admittedly, it ran a bit longer than the earlier test, but still. Well, that's weird. Never mind. 59. Alright. We saw 60 earlier. I'm not sure what happened there, but now the CPUs are about neck and neck. Oh yeah. Well, that's it. Hopefully you found this video helpful. Thanks for watching and for visiting tinkertry.com.